guys, in today's video we're going to take a look at ethanol and its uses, manufacturing ethanol, looking at its production from ethene and through fermentation, biofuels, carbon neutral fuels, advantages and disadvantages, an exam style question, and finally a summary.
Let's begin by discussing the uses of ethanol. Ethanol can be regarded as the most important alcohol, and you can see its structure here. Our ethanol has two carbons in its carbon chain, meaning that as we'd expect, the stem is eth, and you can see the hydroxyl functional group here, giving us the ending of ol. Ethanol is hugely useful. It's used in perfumes and cosmetics, and it's contained in alcoholic drinks. Now, through the process of distillation, our ethanol can be concentrated, and we'll find that drinks such as spirits will contain about 40% ethanol, wines contain about 12% ethanol, and beers around 5% ethanol. So now we've looked at how useful ethanol is, let's take a look at how we can manufacture our ethanol. Ethanol can be made in two ways, by the fermentation of sugars or by the hydration of ethene, an alkene. So let's take a look at both of these ways in a bit more detail now. Let's begin by looking at the fermentation of sugar. Well, the process of fermentation can be utilised to produce ethanol. So through the process of anaerobic respiration, enzymes from yeast can break down our sugar molecules, and they break down the sugar molecules, which have a formula of C6H12O6, you may recognise that as the chemical formula for glucose, is broken down to form two molecules of ethanol and two molecules of carbon dioxide. Now, these sugar molecules are derived from carbohydrates, and the carbohydrates themselves come from crops such as sugar cane and sugar beet. Now, the ethanol that's produced in this way can be called bioethanol. Now, biofuels are fuels that are derived or produced from renewable biological sources. So in this way, our ethanol can be called a biofuel. Now, the conditions under which the reaction takes place are absolutely essential. If we take a look at the temperature, at low temperatures, the enzymes in the yeast will work too slowly. And at high temperatures, the enzymes change structure and no longer work efficiently. So therefore, a compromise must be reached. And that compromise is about 35 degrees Celsius. It's not too low that the enzymes will work slowly, and not too high that it will denature and disfigure the enzymes. The reaction vessel is also incredibly important. The reaction vessel must be kept airtight, and this is to prevent the oxidation of the ethanol to ethanoic acid on exposure to air.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today, and together let's make A-level chemistry a walk in the park.